Okay, so this is an example for graphing a trig function. And I wanted to put this up because some of the answers in the back have these vertical lines that people ask about, the dashed lines. And they're really invisible lines that you can see only because they're dashed, that we use to help us graph these. So I've chosen, I guess, this tangent and put in all these numbers for all the A, and of course, alphabetically I said B, but it's A, C, F, P, B, D, because remember, A and C are outside. That's that -2 and 1. F is the function. P is the period for this function normally. B is this coefficient for x that's been factored out. And D, after you factor out that coefficient, is what's left inside here. Remember, this 3 means it's really 1/3 as big as it was before. And this subtract pi over 4 means it moves to the right. So what we're trying to do, I guess, when I use these steps is to show you how to set up your window to graph this. So A is -2, so I'm going to make sure that I remember that this thing needs to be flipped, because when A is negative, it flips vertically up and down. C is a 1, that moves it up. All of these are vertical movements for the outside the function. The function tangent normally looks like vertical asymptote, and then starts down and ends up. It'll be flipped over for this one. The period normally for the tangent is pi. B is this 3 on the inside of the function. And P over B is the new period for this graph. It's really pi over 3. Used to be pi, now it's 1/3 pi over 3. And the D, pi over 4, and that moves it to the right. So our graph, if you look at this sort of in general, is a graph that is moved up and to the right. So I'm going to focus more on that first quadrant. Now remember, for the tangent, it's a little different from all the others. You're moving that center point, this point right here. You're moving it and then spreading out from that point to get the vertical asymptotes. So first of all, I'm going to move this center, and you use this order, right? 1, 2, 3, and the 4 is the P over B. So you move it up 1. Now this 2 stretches it, but it's going to be hard to show that without comparing it to something else. But just remember the flip, that comes later. The 3 is pi over 4 to the right. So let's call this pi over 4, I guess, right here. And it doesn't really matter. I'm not going to have you measure things exactly. But now that center is moved up and to the right. So now that's the center. And what our textbook has done in the back is put a horizontal line for the new center of the graph. Also, since you got that 2, which is the flip and the right, the next thing is this 4 here. Well, I got interrupted, so if I repeat myself, please forgive me. We are going through and graphing this. We did step 1, we moved it up. That's the new center. That's what they do in the back of the book, put those dashed. It's supposed to be stretched, doubled here, but it's hard to tell that on these 4 trig functions, the tangent, the cotangent, the secant, and cosecant. It's hard to tell whether it's stretched or not because they look sort of the same no matter what. But the flip is important here, the negative. We moved it pi over 4 to the right. We'd call that pi over 4. Pick any number you want. And now this new period for this graph is pi over 3. And what's important, for all the others, we had a starting point and then an ending point. We went over pi over 3 from that. But for the tangent, you have the center line here, and then you take half of your period and go right and left. So half of pi over 3 is pi over 6. Now, pi over 6 is smaller than pi over 4 because 1/6 is smaller than 1/4. So I'm going to say this is pi over 6 to the left, and this is pi over 6 to the right. So you can say it's pi over 4 minus pi over 6 and pi over 4 plus pi over 6. These vertical lines are asymptotes. The graph approaches the asymptotes as you go to infinity, and then it may not approach it on both sides. But remember, normally the tangent starts down and ends up, but now we flip it. So it starts up and ends down. Put a little arrow there. But it approaches these vertical asymptotes. This is the center of the graph. That's what those dashed lines mean. That's what I expect to have you see on the test. So when you're asked about a graph and you see these vertical dashed lines, asymptotes, horizontal dashed lines, I don't think I'd do the horizontal dashed lines on the test. You're going to have to determine where that center is moved to. So I hope this answers. Now remember, this is only one period. This thing gets repeated to the right, gets repeated to the left. Your calculator will show all those. If you want to just see this, you make the x min this value, the x max this value. And then to look at any of these that go to infinity, like tangent, cotangent, secant, cosecant, you go from the center like up 5 and down 5, something like that. So if this starts at 1, you can go up to 6 and down to a -4. And that's what this graph should show up here. Let's check our work. Let me go get the calculator. So, turn it on. Clear out this stuff. Y equals, clear out that stuff. 1 minus 2 tangent 3 left paren x minus pi over 4, pi over 4, close the parentheses, close the parentheses. That's our function. If this were cotangent, you could write that as -2 divided by tangent, and you get the cotangent. Same thing with the secant and cosecant. Use the cosine, 1 over cosine for secant, 1 over sine for tangent, or for sine, cosecant. Now we make our window. Now this pi over 4 minus pi over 6, you can even put it in that way. Pi divided by 4 minus pi divided by 6. And that's the x min. You can put in the pi divided by 4 plus the pi divided by 6. And that'll give you the x. Oh, that was wrong. Let's try that again. Pi divided by 4 plus the pi, not the e, divided by 6. Okay. The scale, I'm going to say pi over 6, just because that's sort of the smallest nice number. Y min, I'm going to take this to a -4 and to +6. And we'll see how this thing graphs. So it should start from the top and come down. The asymptotes are at the right side and the left side. If you want to see where that center is, the dashed line, remember that's a horizontal line at 1, you can go into the y equals, and for y2, y equals 1. And now when you graph that, you can see that's the center of the graph. The vertical asymptotes, if you want to put those in, you can, but they're right at the edge of the window. So this is looking the way it's supposed to. Now it's not as skinny as mine, because the window makes it pretty wide no matter what. So, if you have a question on how to do these, I hope this helps. I hope that helps on the test. We'll see if you need this. I'll try to put this up as quickly as possible for you to get at YouTube, but you'll get to it using my LSMSA, and I'm going to call it Trig Chapter 4 Graphing Example, I guess, or something like that.